Hey, this is Richard. I'm going to do a walkthrough of the code of Sympatico because I haven't done a Thinkscript tutorial in kind of a long time, and there's some cool things going on in there. So you can, whatever, follow along at home. This is launching tomorrow, so it kind of places in time where we're at now. So all of this is really fresh. So I've just finished, working through what is happening in this script, especially the cool parts where it's got the indicators. So to start off, this is Sympatico, which is a overlay of sympathy ticker on whatever your current chart is, and it normalizes it by attaching it to the VWAP. So the percentage from VWAP of each of the variables, high, low, open, and close. And then VWAP, obviously, that's got, it's volume weighted average price, which means that it takes volume into account in how it moves. So actually, we're using all 5 variables to place these in a relative way that lets you say certain things about them, which is what I love doing with programming. So this is what it looks like. I do have another video that goes through all of the features and pieces and how it works and why it looks the way it does. But I want to focus on how it works because it's doing things that I hadn't really thought of when I first started and ended up being really cool, and I can't wait to really trade with it and see how it changes things. But the idea is that I wanted a real-time way of overlaying the ES index on top of Apple because they often run together. Not often, it's like a one-to-one movement between those things, and when there is divergence, it's something big, like Apple's earnings. They had some bad news a couple of days ago that tanked the stock. So there's a lot of things like that that are just sort of, make it interesting to trade, because when it diverges, that's when the important stuff happens. So the first thing we need to do is overlay, and when you have these inputs, that's a setting on the in the settings for the study. So you can see that sympathy is ES, and it'll let you. It's a picker because the way Thinkscript works is that whatever you tell it, it uses its Q based on whatever value you give this variable, and then it'll put up the right type of input element for that. So because this is a text box, they think it's a symbol, which it is. And actually, I think it's because it's a symbol. And it'll let you type in other symbols and use it exactly the same way you would the symbol finder in your main charting. The rest of these are just the variables that kind of go through what the study does, and I want to jump to where the magic happens, because we've got a lot of initialization here. And this is where the magic happens. This is it. This is the guts of it. I mean, all the rest of this, all of this is about making it look pretty, and making it ping sometimes. So what's going on here is that we're gonna create a plot based on this open adjusted. So we have open, close, high, low values here. Ref in this case, I had been playing with a bunch of different things. This should really just be VW, is the local VWAP of whatever your current chart is, and then SREF is the sympathy VWAP of your sympathy. So the way we get these is you can pass parameters to open, low, high, close, and volume. Actually, this is a cool way to do an awful lot of things. In this case, we're passing it a symbol, and that's going to be the sympathy, which, that's this variable up here. That's the when it starts out, it's the ES index. And so the sympathy is gonna be in whatever chart frame we're in. So if we're in the 10-minute chart, that's what the sympathies, it's going to be the 10-minute candle of the sympathy. So I go and grab those for open, low, high, close, and volume. So this is all 5 of our variables that we have for being able to build candles. So the VWAP, we're actually calculating it here, and the VWAP is the close times the volume divided by the volume, and that's over an EMA. So the EMA length here lets you pick how far you want it, and it defaults to 12. And that's, I mean, if we hadn't passed any length parameter, it would default to 12 because that's what the exponential average does. So we're just creating an EMA here with a variable EMA length. I found that 12 is actually fine for everything I'm doing. What happens when this is smaller is it weights the closer candles more, and it forces VWAP to adhere more closely to the candle itself. So it will tie the candles together more closely, so there won't be as much divergence. And if it's bigger, then there will be a lot more divergence. And the alerts and indicators are all predicated on that 12. So, I mean, if you switch it, you may have to tweak the code to fix it. So anyway, so we've got VWAP. We've got a vertically volume-weighted average price. That's one of them is for the sympathy, and that's, so what we're doing is we're taking this piece here is just taking the percentage difference of each one of these variables from its VWAP, and that can be positive or negative. It doesn't really matter because of the way we're doing this. So you take the sympathy's percentage difference from VWAP, which is all this is. You take the open minus the VWAP, and then divide that by the VWAP, and that's all it is. Which, you know, we're calculating up here. And this ref is the current VWAP. So what we're doing is we're adding to the current VWAP, we're adding the VWAP times the percentage of the sympathy ticker's VWAP. So we are translating the sympathy ticker's open, close, high, and low to its VWAP, like that percentage, to our VWAP. So that's how it's nailing it together here. In a way that lets it breathe, you know. So when the tickers move, they're trying to be tied together, but if one wants to move further away than the other, it acts like a rubber band, which is pretty cool. It's pretty cool to like watch it work in action. And like I said, the rest of this is just you know, making it look pretty, because we've got we're defining the global colors here, and then here all we're doing is just plotting out directly the open, close, high and low, and then building the cloud from that. The cloud is something else that I wanted to talk about a little bit, because I don't think people use them very much, and I use them to great effect in the Jimmy Momo zones study that draws out supply and demand zones, because I wanted them to flip from green to red, and I also wanted them to be transparent, and there's not a way to do that. You can't draw rectangles. Which is really frustrating. You draw lines, and then, you know, so I experimented with a lot of different ways of using it, but I ended up with a cloud. And normally a cloud is used as something like, it's just the difference between two values over time, and then it plots them as a little ribbon. And so for something like an EMA, it's really graceful. It looks like it's turning and spinning. It's smooth. With the Jimmy Momo zones, and actually Bell Lines, interestingly, uses clouds to draw in the extended hours time. And that's how they can be transparent, and you can set whatever color you want. And it's because it uses opposite infinity, and so it draws it only at, you know, if it's during extended hours, then it draws a cloud, and then it shuts off as soon as it goes to false, and so it works great. I mean, for something like that, so you can mess with it, and that's kind of what gave me the idea to use it in the Momo zones, which just flips back and forth the same two variables, positive and negative, and it lets you, or not positive and negative, but it just flips them back and forth, which changes the color of it, and then it extends it out infinitely. So here, all I'm doing is passing in. So the first thing we've got is this: the O, C, H, and L are the lines, and the dots, and that's one way to show it. So if we choose in the input to show lines, if show lines is yes, then we show it, and show dots. So you can actually have all of them showing at once if you want to. And then there's the cloud. Once we have the open and close, the O adjusted and C adjusted, then you can build a cloud out of it. And so what we're doing with this cloud is, if we're showing the cloud, then show it O adjusted, otherwise not a number. So like that, not a number is defined up above as double.nan, which is, it's not 0, it's nothing. And once you see that, that means there's no value plotted. So the plot disappears. And then it does the same thing with the close. So it's just the opposite. So this is the open and close cloud. And then once we draw the high and low, this is the wick cloud. And it's the same thing. And then it just picks, here we have to be a little more careful about knowing whether it's a red or a green candle so that we can change the color value of it. And that's how it sort of flips between here. It just sort of, because originally I was trying to color in the candle somehow, and clouds just don't do that. But when I took off the lines and dots, it actually became a really great visual way of interacting with this data, because this cloud is the curve that outlines the wick. This is a wick cloud. A body cloud would work the same way though. So it outlines the path of the wick. So with this, like, it's just as if you like connected all of the wicks with a line and then curved it a little bit. That's what you would see here. And in fact, we can see what that does if we, oh God, I hope that wasn't a bad change I just saved. So what we can do is switch, if we go into edit the study and then pick Apple here. So we're overlaying Apple on itself. And that's the problem with studies. When you go in and update them, you have to hit tab, because otherwise it doesn't stick. Oh, come on, tab. So now it'll stick. So when we look at it, and you can see it's actually drawing that line now. So this will help you visualize what it's doing on the ES side, is that it's drawing the line between the wicks here, and then we can turn on the body so you can see that as well. Whoops, wrong study. So if we show the body cloud as well, then you can see that the body is what's getting filled in here. So it's just from here to here, and that's what starts the cloud, and then it goes from this open to this open, and then on up. And then it closes it out because it flips to red, and then you can see how it works here, which is it's a pretty cool way of visualizing that sort of data, because it's relative, and it gives you a good visual distinction between the two. But more importantly, it lets you very quickly at a glance see where something is in relation to something else. You can see that this is really far down, and that's it's at an extreme, which is where these arrows come in. So what I wanted to do once I made a study, and all of the best studies can be turned into trading indicators. If you have a way of quantifying, like, why are you doing this in the first place? What are you trying to see? Well, I wanted to see the extremes, and so sure enough, if you plot those extremes, that lets you create an indicator functionally. I mean, this is these are buys, these are sells. I mean, it's pretty clear that you can capture an enormous range here. Just by paying attention to the indicators. Not all the way. I mean, you have to have common sense here, but it's a great way. And then you can attach alerts to them as well. So when they ding, you know that it's serving up something tasty. So that's down at the bottom here, and that's this overextended. So what I did was I created the extension variable to be a percentage between the open and the open adjusted. So this is the percentage difference between open and close between the sympathy. So I mean, it's really just this is the percentage difference here from each other. And from there I can hit, like, the extension high is if we're using the body, then we use these, and if it's red, then we either use C or O, because it's got to be the top. And we could have just done max between the two. That would work too, either way. And then the extension low works the same way. We're either picking between the body top and bottom or the wick top and bottom. And then the overextended high value is just whether or not this high value is greater than or equal to this percent. So the percent is that's actually where the magic happens. That's defined all the way up here. You can do it manually if you feel like going through and giving it a number. If you know what you're doing, you can totally do that. Or you can use IV, which is the implied volatility calculation. I'm not even sure how this works behind the scenes, because normally IV is a part of the like Black-Scholes calculation for options pricing. And so I've seen the functions. I just don't know them off the top of my head. But what this is a gauge of how much this stock is currently in percentage-wise moving. So between 0 and 1. So then I multiply that by 0.01, which gives me the factor. It's got to be, and this was from trial and error, figuring out that the move difference with ES and Apple, this is tuned for that, is somewhere around 0.003. So 0.03% difference between these things is the extreme. So that tells you something about how closely they track with each other. That's a really fine difference between the percentages that these things normally move. And so, and the fact that you can use that to predict the extremes is pretty incredible, because that's just not much movement at all. And I've tested this on other things like Tesla and Amazon and Microsoft and Disney and all of those big ones that track this index more or less. Apple, I think, does it most closely. But they all work the exact same way with the same tolerances, which is just incredible. So what we're doing here is using that volatility to be the judge of how to judge the percent difference. So obviously, this is a higher volatility here because the movement is bigger. And so when this percentage actually overcomes, when that volatility overcomes that percentage, then that's actually pretty serious, and that's where it actually draws the arrows here. So that's how we can see down here when we run this. This is whether or not this extension high is greater than or equal to that percent change. So once we have that, that's basically our arrow. That's what this is. This overextended high. This actually should say arrow, but this is the arrow down, arrow up. And so what I wanted to do was there's an indicator that says whether or not it shows up within the trading day. And I did that actually because of a strategy that I wrote. Maybe I'll go through that in another video. Strategies are just like any other study, but it lets you place fake orders, and then you can run reports on it to see how well it did. And so I did that with this. And ran it, and it did pretty well. Just buying at the and stopping out at a reasonable, like if you buy it and then the price dips below your buy price, then it stops out. But if it doesn't, then it captures this whole move. It goes all the way up to this, and when this breaks that and creates an arrow, then it creates a sell event. And that's, the robot can capture an awful lot of, especially when it's dumping the trades before they go too negative. It can capture a lot of movement that way, which is pretty cool. So that's really all this is doing here. The show indicator arrows is just whether or not the arrows show up at all, and then it's the overextended high. So if it's overextended high, then we put the arrow at the high value, and if it's at the overextended low, we put it at the low value. And that's all the indicator is. It's literally just whether or not this percentage difference in the variables is greater than or equal to this percentage that we picked out. And because we're basing the percentage on the volatility, that is variable over time, and so that percentage is going to be based on the recent price action. So it'll work on anything, and no matter how volatile it is, it'll work with its own volatility as the factor within how it determines what it's going to react with. Anyway, so I thought that was kind of cool. There's some debugging stuff that shows up that helps you kind of visualize what these percentages to let you put in your manual amounts. But that stuff's not very interesting. The really cool stuff was this bit right here, where it's all it's doing is taking the percentage from VWAP of the sympathy and plotting that onto our VWAP, our local VWAP. So, I mean, obviously, if these two aren't tracking at the same rate, this self-corrects to make sure that because we're pasting it against our local VWAP, we're only taking the difference between, so if as this approaches the VWAP and passes through it, even if this is not approaching, like, this is our VWAP, it doesn't matter what our price action is doing, we don't care, which means that the sympathy can go anywhere in here, I mean, and each candle it'll try and pull it back using this formula, because it's plotting it against the next VWAP. So they try to tend to converge, and because of that convergence, you can see pretty dramatically where our local price action diverges from the sympathy. And that's why I like using the candle cloud so much, is that it becomes really obvious when the entire thing is completely separate that this is overextended and that there's probably going to be a selling event. And sure enough, that's where it went. So, oh my God, what changes did I make? No, I'm not going to save those changes. So anyway, that's how this works. And if you have any questions, you can find me on Twitter most easily. And otherwise, I mean, I'd like to hear how you use and extend this.